Hey guys, thanks for having me. Okay, let's get into it. So, first, thanks for having me and thanks for this organization. The event is great. I'm Daniel from Tyco, and I'm going to talk about multiple layers and multi-layer roll-up designs and cross-layer communication. Those who don't know what Tyco is Ethereum equivalent or Type 1 Zk EVM. And yeah, let's jump into the middle. So the first section of the presentation will be about the multiple layers, why we need them, or how it tries to tackle the scaling problems. And I will touch the point of inception layers Tyco is trying to push towards for. So first, a little bit of an introduction. So what you could see here is the network utilization of the Ethereum. So what you could see is like for 3 years, Ethereum is kind of at the edge, so full utilization. You can see here there is a dip, but it should not mislead you. It's just when the EIP 1559 math went live. So basically, if we would be above the 50% of block gas target, then the base fit would be exploding. So this just means that we are at the edge. What it implies to be on the edge, so to be something where we are utilizing the network. It usually, from a user perspective, from a user point of view, we see like network congestion, right? So the more transactions are coming in than the network is able to process. What comes with it, so it also implies that we need to pay more to block builders or validators to include our transactions. So this is why we could see that those fees are exploding, right? Yeah. Okay, so in order to get to the layers, I would like to give you a short recap of how we get there, how Ethereum turns towards the roll-up-centric roadmap. And first, Ethereum tried to be a chain who scales it all, who solves its scaling problems alone. Via shards. Shards are multiple. Shards are like, they would fractionalize the network into multiple portions called shards, and those shards would have its own state, and they would synchronize via a beacon chain or a coordination layer. But then they reiterated the plan, and now they are leaning towards a more roll-up-centric roadmap with blobs. Blobs is a new transaction type. It's just like a regular transaction, except they can carry large amount of data, and it's much cheaper than the current call data. It expires. This is where L2s could put their state differences, state transitions, the transaction list, or whatever they want. So this is why we see multiple layers emerging, because Ethereum wants to scale with the help of layer 2s. I would go into the whys more. So we already talked about the throughput, right? So the network congestion, then the cost efficiency, or actually the high gas cost. But there is more to it. And from a maintenance perspective, or from Ethereum's perspective, that's the problem of increasing state. So so clients running Ethereum does not have the same resources as an angry girlfriend. There was an excellent presentation last year, ETH Prague, from Peter Szilágyi, but I just give you a recap or a TLDR, but if someone wants to have it, look at it on YouTube, please. So basically, let's say Ethereum tries to scale and we are tuning some parameters. Let's say these parameters are like a TPS, or like rather the gas use per second. So what happens is that it would speed up the growth rate, and if it would speed up the growth rate, then it would also like it would require more writes to disk space. But in order to avoid that, because it's so intense, or gas intense, or computational intense, we would like to keep more things in memory. But memory is a precious resource, and therefore it would like just higher the barrier for running nodes, right? So the more expensive and difficult to run nodes, the less nodes we have. The less nodes we have, the more decentralized the chain is. So therefore, theoretically, we have like a data availability problem. So this is why, I guess, one reason why Ethereum turned towards like layers. And let's go with the layers. So what you could see here is multiple layers on top of Ethereum, and then I will touch the point of inception layers afterwards. But like, so yeah, if there would be just only one layer who would try to scale alone Ethereum, that would be Ethereum, right? Or there would be one who tries it, that it would tackle, it would need to face the same problems as Ethereum, like the decentralization problem. But for some, sacrificing the decentralization is just fine. It's okay. But then it would also run into the state bloat problem. So therefore, we at Tyco, we tend to think about it that different layer providers and layer solutions, layer instances, are healthy and not, how to say it, just a sec. So healthy competition, I would not rather call them competitors, but rather like complementary subsystems who helps to scale Ethereum, because there will be no one single layer who will does it all. And now going back to inception layers, and this is coming from the term coming from the movie of the Inception movie with Leonardo DiCaprio, of like dreams in a dreams in a dreams, right? So the beauty of being a type 1 or an Ethereum equivalent network is that we eventually be able, it's the same code base, we are sharing the same code base. Our client is able to verify the Ethereum block. So basically, we can just shoot up layers in the layers recursively even deeper than layer 3s, just like that, very easily. Yes, you can see the, okay, so that's the concept of the inception layers. Obviously, it's not only just restricted to type 1 shooting up layers in the layers, of course, but in order to do that with other chains, not Ethereum equivalent, then they would have to maintain 2 concurrent systems, which can be a mess. So this is the one reason we think we are in a good position. And also, yeah, layers in the layers. I wanted to say something, but I just forget it. But what could it be? Layers and layers. Okay. Anyhow, let's go to the next slide. Maybe I might come back if I have something to my mind. Okay. The next topic is cross-layer communication. So let's see, what is cross-layer communication? Cross-layer communication is basically just sharing information among other chains or layers. Basically, bridging is one type of the cross-layer communication, or DeFi protocol on L2 wants to access some data on L1. This is also like via the cross-layer communication. Why is it important? It's a key element of scaling. So without communication, there is no scaling, right? We need to talk to each other. And then there is the efficiency issue. It's like isolated systems usually or could limit the technology. A good example of it is the early days railway systems when you wanted to do cross-border travelings, and then you had to go to the border, disembark, carry the load, uncarry the load, carry it to the other chain, and then continue your journey. This was very inefficient, and this is why we needed those kind of railway standards. Now it's much more smooth, so this is why we need, definitely, it's a vital thing. And obviously, last but not least, some might prefer like cheaper chains or quicker chains, so therefore it's a choice and preference of choosing it, or one versus another, right? The current elegant approach is that there's a synchronization mechanism between L1 and L2, and we synchronize the state route if we want to verify the whole Ethereum, or just the storage route if we are about just verifying a specific smart contract like a bridge. And with a Merkle proof or a Merkle-Patricia proof, Merkle inclusion proof, we can just verify the data what we are accessing on the other chain. It's good, it's working. we are using it. A lot of the participants in the network are using this approach. The problem with this is that we need to bring the data manually on chain with the proofs, which is very like cost intensive, the proofs and the data. And basically that leads to the next slide, or the last slide of mine, which is a research paper from Tycho, and our CTO Greg Davos put this together. Unfortunately, the link could not be seen for whatever reason. It's under the subtitle, but there is a research paper on ETH research from Greg Davos, which basically says that there is maybe a more efficient mechanism to do that. We are synchronizing the state roots to the L2s, and it's only possible with EVM equivalent chains plus if we are using the same data structure. So actually, like Ethereum equivalents, not only EVM equivalent. But so we're synchronizing down the state root, and when an L2 contract tries to access data on L1, basically the precompile is getting activated, and via this precompile, it changes the state root to the L1 state root, and it's actually calling the L1 smart contract during the precompile is active. It's done by the client, and it has the advantages of very efficient, because we don't have to put the proofs on and the data on chain, and it's very easy. Like it seems like you can just call an L1 smart contract data from L2. It's very convenient and simple to prove. So L2s that already proving EVM bytecode with Merkle Patricia tries can just easily like switching the context, then the state root, and then calling the data. It has also some drawbacks, of course. Like everything is that the L2 needs to have access to L2. L2 nodes needs to have access to L1 state, and they have to run in low latency communication, otherwise it will not work, or there has to be an L2 node which is a merged L1 node, L2 and L1 node together, but it's very memory and resource intensive again, so most probably it's not going to work, or would lead to higher hardware requirements barrier. And it only depends on or only works for chains that the L2 already depends on, so otherwise we would need to implement different kind of chains or data structures within the client. So it's also like it could be very hardware intensive. One thing I forgot to mention with the layers, and I just figured it out, is that why I'm talking about multiple layer in the layers, like layer 4s and recursively even deeper layer 5s, etc. Personally, we don't think that we need layer 4s or layer 5s, but to onboard the next billion users to the ecosystem. If we want to onboard them into like L2s, then we need to put, most probably we need to put, it depends on the mechanism, but we need to put their proofs onto L1, which is very costly, very expensive. So this is why we think that we might need L3s. And even though, like, let's imagine, I was working on a gaming company, a mobile company, and they were like trying to build up a blockchain department. So what could happen is that we have this beautiful solution from Tycho, is a type 1 network, and they want to have an own chain. And what they could do is like simply shoot up an L3 network on the top of Tycho, or others like Scroll or Polygon can even like launch on the top of L2. Basically, it's an Ethereum in an Ethereum. So they could just use Tycho's data infrastructure, chain, and clients to shoot up their own network within our network, or top of our network. So they could even use it for application-specific purposes, like gaming, as I mentioned. That was it. That was it in a nutshell. If you have any questions? Okay, I have 1 minute left, so feel free to, or...
Wonderful. We might have time for like one question if anyone's got one. Oh, we've got one at the back. That was the quickest one. We've got literally 30 seconds, so... Quick.
Do you think atomicity is possible between different rollups?
Sorry, could you repeat?
Atomicity.
I could not really...
Atomicity, like
Atomicity.
atomic transactions between different rollups.
I would say between Ethereum equivalent rollups, definitely, sure, because it's easy to implement. Otherwise, I'm not 100% sure, or when we will get there. I hope it answers your question. It's still, so this research paper is still in research phase. So we will see if it is feasible or not. We will see. We have partners, I think Scroll is also interested, and other participants trying to explore synergies, how we can implement this in the future.
Thank you. Give everyone a round of applause for Daniel, please. I hope we get there.
Thank you.